Hello guys, my name is Giacomo. In this video we're going to review ModMyPi PiOT board.
Hello guys, as you might have guessed, this board is going to be child's play. In the latest period we have seen quite a lot of projects coming up on Kickstarter. This wasn't one of them, but it's nevertheless a quite interesting project which I'm quite honored to review. So without further ado, let's go and have a closer look to this new amazing board from ModMyPi. Each board is fully assembled as the ModMyPi PiOT has been created with simplicity in mind. The PiOT relay board can be connected directly on top of the Pi or via GPIO ribbon cable. It also features mounting points for the Raspberry Pi Zero. The PiOT relay board allows you to bond a GPIO pin to relay with the touch of a button. No need to tie pins using resistors, and no need to rewire the circuit when you want to change which GPIO pin fires which relay. Simply select your GPIO pin using the onboard tactile buttons and the 2-digit 7-segment display. Switch that pin high or low to activate your designated relay. The onboard display can be configured to show the Pi's BCM or pin number system for GPIO relay bonding, and also provides visual feedback of the relay on-off status for ECE monitoring. In addition to providing menu access for setting configuration, the display can be used to test relay before configuring them with your Pi. The PiOT relay board uses low current, about 100 mA PWM, to significantly reduce the current required to hold the relays on when compared to other relays board. This means that the relay board can be stacked up to 5 without requiring additional external power. Warning: relays can be used to switch large voltage and currents, so be extremely careful when undertaking any work with this type of powers, because it can kill you. The ModMyPi PiOT relay board features 4 OMROM relays for switching up to 10 amperes at 250 volts or 10 amperes at 24 volts. It has 4 tactile buttons for GPIO relay bonding. It has a 2-digit 7-segment display for visual feedback and setting control. It has a microcontroller GPIO relay setting and switching. This is based on a microchip PIC microcontroller. It has 40 points Raspberry Pi GPIO modeled input. The PiOT relays are also compatible with both 3.3 and 5 volts, so you don't need to worry about adjusting your input voltage depending on your microcontroller. It has low holding current via PWM. It is stackable up to 5 modules without requiring any external power. It provides multiple startup modes to negate boot GPIO chatter or delayed handshake, and it has Pi Zero mounting points. ModMyPi is one of the biggest shops out there which take care of selling and producing products for Raspberry Pi, but not only. You can certainly find information about the PiOT on the product page, on which you can obviously also certainly buy the product. And at the bottom of this page you can find additional links, one of which is quite important because it was going to lead you to the wiki page. Any great project will not be a great project without the necessary documentation, and this wiki provides ample example of what documentation should really be about. It is absolutely extremely detailed and rich in content and examples on how to install it, on how to run example Python code, and even an introduction on relays. So I really would advise you to check this page and get all the information that you need before you start, especially if you're going to be dealing with high loads and high voltages. So at this point we're going to look at the installation page. Which will tell us all about how to connect it to the Raspberry Pi, depending on which Raspberry Pi you're using, which mode you're going to be connecting to the board with. And then we are also going to check all the basic informations that are needed in order to set up the board via the buttons provided, how to interpret the display messages, and finally how to run some code and install the various dependencies that are required for this code to run. I went ahead and connected my Raspberry Pi via the ribbon cable as shown in this picture here, and I've also started an SSH session to it and installed TightVNC so that we can connect directly to the GUI and see what happens from that point of view. The example page asks you to install the Python TK, which, if you are probably, as I am, on the latest version of the Raspbian Jessie, will not be required for installation, but it might be, so just run the command just in case, and then clone the Git repository where the ModMyPi scripts are contained into via running this command here, which is also present in the example Python page of the wiki. So once you've installed the dependencies and cloned the Git repository, it is now time to run the script as shown here. So we will do just that. We have now a folder called PiOT PiOT relay board, which contains the script. So we can run it by typing sudo python piot piot5.py, and that brings up this GUI, which will allow us to control the various GPIO pins and the relays associated to them. There is a little trick that needs to be done in order for this script to run off display 1, which is the one I'm using for TightVNC session, but I'll add that to the main article on my website. In the meantime, it is probably now time to look at the board up close and see how do we switch between modes and how do we assign relays to the various pins. So let's just stop this session for a little while, and then let's focus on the board and how to set it up in order for it to do what we want. So I've placed the PiOT board next to two reference boards, one showing the the BCM numbering and one showing the physical numbering, just for comparison. And the first thing we're going to be doing is check how to do the testing of the relays, and so how to enter test mode for the PiOT board. In order to enter test mode, you just press for a short while the button next to the relay you want to test, and as you move one button to the other, you will see that a different LED comes up showing you which relay you are testing, and this is the last one. So let's test this first one. You will notice that there are three labels here, one which means normally open, one it is the common wire, and one it is the normally closed, and that regulates the behavior of the cables that will be connected to the relay. So any cable that wire that you will be connecting will either be onto the common and normally open or to the common and normally closed. With the multimeter that I've got, I've set it onto the connectivity mode, so that when you short the wires, it will produce a sound. So that's how we're going to test the relay. As you place one on common and one onto normally closed, it will produce the sound on the buzzer. When you move from that to common and normally open, it won't until the relay will be activated. So we go into test mode, and sure enough, when we press again, sorry, that's a different mode. I'll quickly go back to that. Okay, so we are okay, so we'll hold and press. We are in test mode, and when we activate the relay, the normally open is going to be short, and the normally closed, let's go into test mode again, will then be open at that point. So now let's see how to make the associations between the relays and the GPIOs, and what is the default setup that the board comes in with. So if you press once the button next to the relay, it will show you the BCM number to which the relay is associated to. So in this case, this first relay is associated to BCM number 2, which is physical number 3. The second relay is connected to BCM 3, the third relay to BCM 4, and the fourth relay to BCM 14. So let's say we want to change the first relay, which is associated to BCM number 2, to say, I don't know, number 17. So we press the button next to the relay, and once the BCM number is displayed, let's do it again because it goes quickly. We just keep on pressing the button one after the other, moving through the BCM GPIO's numbers until it shows the one we want to associate the relay with. So now it is associated with GPIO number 17. If you were to be more comfortable with the numbering for the physical numbering, then you need to enter into a specific mode by pressing and keep pressing the two buttons at the extreme. So we keep on pressing them until the display changes, and when it changes, it will show you that the numbering displayed normally is with the BCM. If we press the rightmost button, we will move onto different setups. So we won't go into detail of those as yet, but let's just focus on these I/O association. So we are now on GP on BCM, and if I press this button here, I will move on to physical numbering. So BCM, physical numbering. To exit the mode, the setup mode, then we press and keep press the rightmost button, and we're now back onto the monitoring mode. If we now press any of the buttons next to the relays, it will show the physical numbering instead of the BCM. So we said we were associating the first relay to BCM number 17, and it now shows that it is associated clearly to physical numbering 11. So it is the same GPIO, it's just a different notation. So let's go back and do it again. We go back into setup mode, and then change the physical numbering back to BCM. Press the right button, go back into monitoring mode, and sure enough, the numbering is back to BCM. Now that we've seen how to make all the necessary preparations, we can go back to the GUI and to the application that has been provided via the GitHub, and finally test it with the setup that I put together. I've connected 4 PC fans to the relays so that we can visually see every time that we activate one of the relays which fan does start up. So let's check the first one. We knew that the first relay was associated to GPIO2 BCM notation. So let's click the button here, and sure enough, one of the fans will start up. Let's check the second one, third, and fourth, and all the fans are spinning.
We hope you enjoyed this review
And that you find all the information provided useful, and that can help you for your projects with this new board from ModMyPi. This is it for today. That's all, folks. Please subscribe to the channel and visit my website at garagetech.tips. Thank you, and bye-bye.